Okay, so this is going to be a short session, and we're only basically going to look at only accommodation. That's what we're going to look at, and then we'll also look at something to do with how the eye controls the amount of light that enters, and then enters the eye and reach the retina. Those are the two concepts that we are going to look at. I'm sure some of you know accommodation in relation to a place where you're going to sleep. That's what often we call accommodation. But in biology, we look at accommodation as a process that the eye employs to be able to focus and regulate the amount of light that enters the eye, such that you can have a clear image. Okay, a clear image. If you don't have a clear image, the term that we use when you don't have a clear image is blur. The image will be blur. So if I can write that word here. So if you say a blurred image, that means that image is not clear. And maybe we can go to this slide here to get that picture. So if you see this image here, you see this doll is not clear. It is actually a blurred image. Whereas in this image here for near vision, the doll is very clear, yet the tree is blurred. Okay, so what we are saying is that if the eye cannot focus the right rays properly onto the retina, you will not have clear vision, you have a blurred image. So in the process that the eye uses to make sure that the image is clearly focused on the retina for clear vision is what we call accommodation. So this accommodation is achieved through different organs of the eye, different parts of the eye. The ciliary muscle, the muscles, the suspensory ligaments, and the lens. Okay, those three parts play an important role in the regulation of how a clear image can be formed in the lens. On this image, I want you to pick two concepts related to how the rays approach the eyes, or whether the object is at a far distance or whether the object is actually near. So let's start with when the object is near, with the first image here. So this is where we are. You will notice that the rays coming from the right rays are represented by a line, and then that is what represents the light rays, where they're coming from and where they're going. Okay, so for an object that is actually near, the rays are diverging. Okay, they are diverging rays. Diverging. For an object that is far away, the rays approach our eyes when they are actually parallel. When they are parallel, they cannot meet. That's what we mean there. But ultimately, in both cases, a focused image will always be formed on the retina. Always the retina. regardless of whether it is far or it is near. So the ability of the eye to focus far or near objects onto the retina for clear vision is what we call accommodation. So that is something that you need to note there. The second thing that is very important relates to the size of the lens. So starting with the near objects, you can see that this one is thicker. The lens here is thicker compared to this one. So this one is thinner. You see, the lens is thinner. That is something that you need to notice there. Okay, so let's go to what happens, what makes the lens thinner or thicker. What does what? That is what we are going to look at. So before we look at that, maybe we can remove this. Remove this for so that we have some good space here for us to be able to understand what we are talking about. Okay, good. So here, what do we want to achieve? When we have an object near our eyes, the rays are diverging, so therefore we need to refract them more, bend them more. Okay, more refraction is needed here, so that we can achieve this. More refraction. Here, less refraction is needed. So that's why we need to have this as thin and this one as thick. Okay, I hope that is also clearly noted. So let's look at this image, see what it will tell us. Let's look at the three parts that play an important role in diffraction of the eye. Of course, we all know the lens here. We also know the ciliary muscles here, the yellow part, and then we have the suspensory ligaments all around the lens. Okay, so those are the three parts: the lens, suspensory ligaments, and then the ciliary muscles. So when the object is very far, like in the first place, we want to have the lens thick. It has to be thin, okay, such that you have less refraction, okay, such that you can converge the rays or focus the rays onto the retina. Okay. So we need thin, just like what we had here. We need thin here. It's the same thing. We need also thin lens here. So how do we achieve that? We achieve that if we make the suspensory ligament more tight. It's just like making sure that it is pulled. Okay, such that the thing becomes more flat and not bulging. For objects that are closer, we need the lens to bulge, such that we have more reflection. Okay, so bulging, when it bulges, becomes more round. Okay, and more refraction of the light rays. Please always remember that for distant objects, the ciliary muscle will always relax, and then for near objects, the ciliary muscle will contract. Okay, so that is how we can achieve a focused image on the retina. Okay, we are saying that when the object is near, you need more refraction compared to when it is very far. The refraction is achieved through the different parts. The cornea, we talked about it playing a really important role. The lens plays an important role, plus the aqueous and vitreous humor also play an important role. But in accommodation, when you're explaining how accommodation happens, we use the ciliary muscle, the lens, and then it's a special origami to be able to explain how accommodation happens. If you have the lens being thick, more refraction. If you have it thin, less refraction. But ultimately, you want to have a very clear image, whether it is a far image, a far object, or a near image. I mean near object. The end should be a clear image on the retina. That's what should be achieved. And we have looked at the difference between a clear image and a blurred image. So here, still emphasizing the same point. For near image, thick lens. Far image, thin lens. That should be very clear concepts that you need to grasp. So the amount of light that enters the eye is regulated by the iris. So it controls the iris. Remember, is a circular muscle. Okay, when it contracts, it constricts the pupil, and that means that little light will be let in, and that will prevent the retina from receiving more light. If you have little light or dim light, the iris, which is a muscle, will actually relax, dilating the pupil and letting in more light, and this improves vision in areas where you don't have enough light. Okay, so that is our presentation on accommodation. Thank you.